Okay, we're going to be looking at practice test 2, second half, problem number 2. We're given a force and we're given that it's equal to y I hat plus parentheses x plus y close parentheses j hat. We draw a diagram of the line along which we want to evaluate the work. So we're asked to calculate the work done in moving from point 0, 1, shown right here, and to point 1, 2 along the diagonal line shown right here, going from here to here. Recall what the dot product of two vectors are, A dot B. There are two forms. The one in particular that we want to use is A dot B equal to AX BX plus AY BY. And we'll recall that this would form FX here, and this would be FY. And work is given by the integral of f dot dr, and dr is given by dx I hat plus dy j hat. So what is the definition of work? Well, it's simply that work is equal to the integral of f dot dr, which we can write based on this scalar product here as the integral of fx dx plus the integral fy dy. Once again, I know what fx and fy are, and I can substitute that into the integrals. Dx, what are the limits of dx? Well, we go from 0 to 1 in the dx axis, and dy, we go from 1 to 2. How is x related to y along the line? Well, it's just a straight line. We see that as x goes from 0 to 1, y goes from 1 to 2, and we have that we can calculate the slope is 1, and we have that the line y equal x plus 1. Now we're going to need that a little bit later. Let's now calculate the work. If I look here, the work is equal to the integral from 0 to 1, x plus 1. Well, how did I get x plus 1? Well, I have y here, all right, and I just need to substitute this y, x plus 1, into that function there. And then we have, it's the integral from 0 to 1 dx. And then for the fy dy, we can substitute y minus 1 because we can calculate that y minus 1 is equal to x. So y minus 1 equal x. And once again, this can be substituted into this x. And we have everything in terms of the integrating variable. Here we have x, here we have dy. Now let's go ahead and consider doing the integral. We integrate from 0 to 1 along the x-axis and integrate from 1 to 2 along the y-axis. And we get 3 1/2 joule. Now the problem asks us to choose another path, and the path I'm going to choose is the one shown right here. I'm going to go along the x-axis at a particular y value, and then I'm going to go along the y-axis at a particular x value. Okay, path shown by dotted line. Let's calculate the work. So let's calculate first along the x-axis at y equal 1. So of course, dr will only be dx I hat. That will only be this part, the first part here. And we calculate yx. This is not a component. This is just indicating that I'm calculating work along the x-axis. And that would be the integral from 0 to 1. 1, since y here is 1 dx, and that's equal to 1. Now calculate the work along the y-axis at x equals 1. Of course, dr here is dy in the j hat direction. When I do that, it's the integral from 1 to 2, 1 plus y. Once again, it's x plus y, but x is equal to 1 here. So we can integrate that, and we come out with 2.5 joules. What is the total work? Well, I've got to add the work done in going along the x-axis and the work done going along the y-axis. And that is 1 plus 2.5 equals 3.5 joules. Well, notice that I got 3.5 joules previously. Is it conservative? Yes, it is, because this 3.5 joules is simply equal to that 3.5 joules. And so, yes, it is a conservative force. End of problem.